lecture series of the subject Basic Electrical Engineering. In previous videos, you have studied different topics of DC circuits. But one major component that you have seen in that all videos was the sources. So you must have many questions about the sources. So in today's video, I am going to explain you the type of sources that are connected in any electric circuit. The electric circuit may be a DC circuit or the AC circuit. Also, I will explain you one technique, that is the source transformation technique. In analysis, or you can say to find the voltage or current in any type of electric circuit, there may be so many type of sources. So you may require one technique to convert one source to another source. So here let's start. Let's begin with the type of energy sources that we are using in any type of electric circuit. So basically, there are two types of energy sources that we are using, and that two types are the independent energy source and the dependent energy source. So let's see first independent energy sources. So in independent energy sources, there are two types of sources: independent voltage source and independent current. We often use the voltage source in any type of circuit, but there is also another type of source, that is the current. Means to start any type of electric circuit, we must need to provide some electrical input to that circuit, and that input provided by this two type of source. So let's see what is independent voltage source and what is independent current source. So you can see this figure. One round small circle is used to represent independent type of sources. So you can see in this figure, there is an independent source. If that is the DC source, then independent voltage source is introduced by representing plus and minus. That means positive and negative sign, just similar to the positive and negative sign of a battery. So if you are using plus and minus sign inside that round circle, so that means it is known as the voltage source, where V is the value of that voltage source. So that first figure is of the DC independent voltage source. In case of AC voltage source, we will draw one small sinusoidal waveform inside that circle. So that means it will be the AC voltage source, and its output is represented by the V is function of time. So V of t. So that means if capital V and plus minus is given, then we can say that this is the DC voltage source, and inside that circle, if alternating sinusoidal waveform is drawn and V of t is given, then we can say that this is nothing but the AC voltage source. But these two sources are known as the independent source, and it is known as the independent source because its value does not depend on any other parameter of that circuit. Its value is fixed, constant. So that's why it's known as the independent voltage. Now let's see the independent current source. So in case of independent current source, you can see these two figures, and in case of again independent current source, we will use one circle, one round, and inside that circle we are using one arrow, and that arrow represents the direction of current flowing through that current source. Direction can be upwards or downwards according to the construction of that current source. So you can see that there is one current source given and one arrow is also given. So we can say that this is the independent current source, and there is no sinusoidal waveform is given. So we can say that this is DC current source. And if sinusoidal waveform, one sinusoidal waveform, symbol of that sinusoidal waveform is represented inside that circle, then we can say that this is the AC current source. But both sources are again independent type of sources, as its value does not depend on any other parameter of that circuit. So these two are known as the independent type of the voltage source and current. Now let's see dependent type of voltage and current sources. So there are so many types of dependent sources. So we are studying here four major type of dependent source. But first of all, to differentiate between the dependent source and independent source, we are using different symbol for the dependent source, and that symbol is nothing but the diamond shaped symbol. In case of independent source, we were using a circle or round shape, but to differentiate it from the dependent source, we are using a diamond shape. So the diamond shape will represent this is an independent type of source, and dependent type of source is nothing but the value of that source is depending upon some other parameter of that circuit. It is not having the constant value, because if that parameter is changed, then the value of that source will be changed. So let's see different type of dependent sources. So there are basically four type of dependent source available. So first dependent source is nothing but the voltage controlled voltage source. So that means this is the voltage source, but its value is controlled by some other voltage of that circuit. Second source is current dependent, or you can say current controlled voltage source. Means this is again a voltage source, but its value is depend upon some other current of that circuit. Third element is nothing but the voltage dependent current source. So this means this is a current source, but its value is dependent on some other voltage of that circuit. And fourth source is nothing but the current dependent current source, or you can say current controlled current source. So that means this is a current source, but its value is dependent on some other current of that circuit. So these are the four types. Now let's see one by one all the types. So first type is the voltage dependent voltage source. So in case of this type of source, you can see this figure, and in this figure we have shown one diamond shape here, and this diamond shape is representing dependent type of source. And in this diamond shape we have used for plus and minus. So this plus and minus is representing this is the voltage source, but same is representing this is the dependent type of source. Now, this dependent voltage source is depending on some other voltage of that circuit, and the other voltage is nothing but of that side, and that side is representing the voltage VI. So the value of this voltage source will be VO, that is V output. So you want to find the output voltage this side. The output of this type of source is dependent on some other voltage given in that circuit, and some other voltage means V1, that is the voltage on which our output voltage is dependent. So for example, I have written that it is 60 V1. So that means our output voltage VO or V0 is equals to 60 V1. So that means if V1 is changed, then 60 into V1 will be changed, and our output voltage will be changed. So this type of source is known as the voltage dependent voltage source. So this will give you the output voltage, but that output voltage is depending on some other voltage of that circuit. Now let's see the another dependent type of source, and another dependent type of source is nothing but the current dependent voltage source. So again, in this case, again we are representing one diamond shaped source here, and in the diamond shaped source we are representing plus and minus sign. So this means it is a dependent voltage source, and from that dependent voltage source we are taking output outside, that is the VO. So we want to find the output voltage VO. The value of this output voltage is depending on some other current of this circuit. So you can see that there is one input side of this network, and from that input side some current flowing through that side, that is there is one resistor connected, and that some current is nothing but the I1. So this output voltage V0 is depending on some other current of that circuit. So we can establish some constant, that is K. So the value of our output voltage will be V0 is equals to K into I1. So that means K is some constant or the factor, and I1 is the current of that circuit. So we can say that if current of that part is changed, then our output voltage will be changed. So this is nothing but a voltage source, but its value is dependent on some other current of that circuit. So this is nothing but the current dependent voltage source. Now let's see the third type of the source, and third type of source is nothing but the voltage dependent current source. So first we need to represent a dependent current source. So how we will represent the dependent current source? So again we are using the diamond shape here, and in diamond shape we will use arrow. So that arrow will represent this is nothing but a dependent current source. So our aim is to find the output current I0, because in this case this is a current source, so we want to find the current at the output side. But again this is a dependent source and the name is voltage dependent current source. So that means the output current is dependent on some other voltage of that circuit, and we can say that some other voltage is V1. So this V1 will be multiplying with some constant. For example, we have taken 0.2. So the output current at this side is I0. So this I output is, or you can simply say I is equals to 0.2 into V1. So we can say that the output current of this current source is dependent upon some other voltage of that circuit. So this is nothing but a current source, but the current source is dependent on some voltage of that circuit. Now let's see the fourth type of source. And fourth type of source is nothing but current dependent current source. So that means in the output side we will draw a diamond shape, we will draw some arrow, and we want to find current at output side. But as the name suggests, the output current of this type of source is dependent on some input current, or you can say any current of that circuit. So we want to find the current I at output side. But this current I is dependent on some other current of that circuit, and other current of that circuit is I. So at output side you can say that our output current is some dependent on some other current of that circuit. So you can see this figure, and in this figure our aim is to find the output current I. But you can see that I is equals to beta into I1, where beta is just a constant and I1 is the some other current of this circuit, and some other current is the current at input side. So beta into I1, if I1 is changed, then the I, that is the output current by this current source, will be changed. So this is also known as the dependent type of source. This is a current source, but this is a dependent type of current source. So we have seen this four type of dependent source that we are using in any type of electric circuit. So this was all about the independent and dependent type of the sources. But in our circuit, in this DC circuit chapter, majorly we are using the independent type of sources. So sometimes the question is that we need to find the voltage or current through any element in the electric circuit, and so many independent sources are given. So to make that analysis easy, we need to convert either voltage source to current source and current source to the voltage. So this technique is very useful. That is the source conversion, or you can say source transformation. So how we can transform the given voltage source into the current source, and how we can transform the given current source into the voltage source. So that means this source transformation is not applicable for the dependent type of sources. This source transformation is only applicable to the independent type of sources because its value is constant. We cannot transform the dependent values. So how we can transform a voltage source into the current source? So the condition to transform the voltage source into the current source is, if we are taking one independent voltage source, then there will be some resistance connected in series with that voltage source. So if you want to transform that voltage source into the current source, then that means there will be one current source, but the position of resistance will be changed. If resistance is connected in series with the voltage source, but in case of current source, position will be in parallel. So in case of voltage source, there will be one voltage source and one resistance connected in series. But whenever you are transforming your voltage source into the current source, then there will be one current source and resistance in parallel to it. So vice versa, if our current source is given, one current source is given, then there will be some resistance in parallel with it will be given to you. So if you want to transform this current source into the voltage source, then what you have to do is you have to transform this current source into the voltage source, and the resistance connected in parallel will be in the position in series with our voltage source. So basic concept is voltage source and resistance is in series, and current source and resistance is in parallel. But the question is, the values of voltage and current will be changed. The values of resistance will not be changed, only the position will be changed. If resistance in case of voltage is connected in series, then the value of resistance will be the same, but the position will be changed. It will be connected now in parallel. So let's first see if our voltage source is given. And with this voltage source, one resistance is connected in series. So you can see that there is one voltage source and one resistance R is connected. And you want to transform this voltage source into the current source. So what is the concept is you can convert this voltage source into the current source. But instead of voltage source, there will be the current source. According to the direction of the voltage source, direction of current source will be defined. Means there is a positive and negative terminal of the voltage source, then arrow will be upwards. If negative and positive terminal is given, then arrow will be downwards. Means in the position of positive terminal of the voltage source, arrow will be down. So this is a current source. You can see that there is one resistor connected in series, but in case of current source, resistance is connected in parallel. So in this way, you can transform voltage source to the current source. But one thing you need to understand is, if you are converting this to network, so it will not change the voltage and current relationship in these two networks. So that means the open circuit voltage of the first network is always equivalent to the short circuit current of the second network. So that means no parameters are changed. Just we have transformed or converted our sources. So now let's take one example. Here one voltage source is given. Voltage source is having the value 10 watt. And one resistance is connected in series with it is having the value 5 ohm. And we want to convert this voltage source into the current source. So what we have to do is we have to first find the value of the current source. And value of the current source is obtained by the Ohm's law. I is equals to V by R. V is having the value 10 volt and resistance is having the value 5 ohm. So 10 upon 5 will give you the value of 2 ampere. So our current source will have the value of 2 ampere and current source is drawn like this. There will be one current source having value 2 ampere and the resistance 5 ohm, which was first connected in series, is now just connected in parallel. And the terminal EB will be connected as well. So this means we can transform voltage source into the current source like this. Now let's see how we can transform current source into the voltage. So to transform the current source into the voltage source, what we have to keep in mind is that in the current source, one current source will be given and resistance will be always given in parallel. If you want to transform current source to the voltage source, then what you have to do is you have to draw the voltage source and instead of parallel, you have to connect that resistance in series. Value is not changed, value will be the same. So you can see this figure. There is one voltage, there is one current source IS, there is one resistance RS, and we have drawn equivalent voltage source according to that current source, and the equivalent voltage source is nothing but the E, and resistance which was previously connected in parallel is now connected in series. But the value of voltage will be changed and it will be again according to the Ohm's law. So V is equals to IR. I is given, R is given, so you can find the voltage V is equals to I. And the symbol of the voltage source again will be dependent on the arrow of the current source. If arrow is upwards, then positive terminal we have to draw this in upwards. If arrow is downward, that means positive terminal will be downward and negative terminal will be upwards. Or you can draw the battery terminal also, because we are talking about the DC circuits. So this was all about the source transformation. So what I have told you in first line of this source conversion, and that was sometimes it is needed to eliminate or minimize the sources to easily find the voltage and current of that circuit. Means if so many voltage source and current sources are given, then either we are converting all the voltage sources into the current source, so now there will be only current sources. And if we are converting current sources into the voltage sources, so now all the sources will be of the voltage. Means either we have to convert all the sources into the voltage form, or we have to convert all the sources into the current. So what after converting all the sources in one form? Then we have to combine that sources. So how sources are combined? Let's see how we can simplify sources. So here so many voltage sources are given. So for example, we have taken two voltage sources and we want to combine these two voltage sources. So the first condition to combine these two voltage sources to the voltage sources should be in series. So if two voltage sources are connected in series, then their value will be added directly if the polarity of that voltage source is same. So if that means plus minus is the polarity of the first sources, that is V1, and plus minus is the second polarity of the second source, that is V2. Then we can, instead of drawing two sources, we can draw only one source which is also having the polarity plus minus, and the value will be V1 plus V2. So in this way, you can transform any number of sources connected in series via one single equivalent voltage source, and our network will be quite easy. If polarity is different, means if the polarity of the V1 source is plus minus, but if the polarity of the another source is negative and positive, means plus minus minus plus, means polarity is not same, then again this source will be converted into the single equivalent source, but the value is not added, but the value will be subtracted depending upon the which value is larger. So if V1 is having the high value or the large value, then you can do is V1 minus V2, and you have to put the symbol of the V1 source. But if the V2 is having the high value, then you have to do V2 minus V1, and you have to put the symbol of V2 in that circle. So in this way, you can convert your sources, you can combine your voltage sources. Now let's see how the current sources are combined. So the main condition to combine the current sources is current sources should be connected in parallel to each other. If two current sources are connected in series, then that is not possible, and you cannot combine that current source. So the current sources should be in parallel. So for example, if two current sources are having the same direction and having the different magnitude, that is I1 and I2, so instead of drawing two current sources, you can directly draw one single equivalent current source, but the value of that two current source will be added. So the value of equivalent current source I is nothing but the I1 plus I2, but the direction of both the current should be same. So next question is, what if the direction of current sources is different? Then again, similar to the voltage sources, we have to subtract the value of that two sources. So if I1 is having the high value, then the equivalent current source is having the symbol of I1, means sign arrow of the I1, and the value will be I1 minus I2 if I1 is having the large value. But if I2 is having the large value, then it will be I2 minus I1, and the direction of this equivalent current source will be the same direction as the I2 source. So in this way, you can also combine the current source. So now, next question is, what if two voltage sources are given in parallel to each other? So if two voltage sources are given in parallel to each other, that means that source is having the same magnitude. Then that two sources are in parallel. So if 5 volt and 5 volt is connected in parallel to each other, then one single equivalent voltage source you can draw, but only that is having the 5 volt value. So that means if two voltage sources are connected in parallel, then V1 is equals to V2. You can convert this type of sources. And if two current sources are connected in series, then you can draw one single equivalent current source which is having the same value as the I1, or you can say I2. So I is equals to either I1 or the I2, because that two current source must have the same value. So this concept is clear if two voltage source is connected in parallel and if two current source is connected in series. So that means in this video we have seen different type of sources, and also we have understood one technique to transform or convert one source into the another form. Thanks for watching this video. Stay tuned.